and we're going to do some further questions related to it's the same worksheet that we were doing that I had sent on the on WhatsApp as well. Now, this question over here, you're being asked to write the expression for KP. So so you're getting a question on KP in this
Sir,
particular
one of the I didn't know how to solve this
this one.
of the fusion.
So we're going to discuss KP. Uh, I think it's this one. So I'm going to teach you KP first. KP was AS. So so let's talk about KP first. Just 1 second. So KP is equilibrium constant related to pressure. But it has, I mean, the values that you're going to take for KP are going to be pressure values. What that basically means is that if you have a reaction, and let's pick any reaction, there is H2 and let's assume that there is H2 gas. And remember, it only applies to or mostly applies to gases. Because gases are the only things that change pressure. Like solids and liquids, they have constant pressure. For gases, if there's more gas, I mean the concentration of the gas. Just 1 second, the board is not functioning properly. Let me quickly. So the question would be solved in this way that it's going to be partial pressure of NO multiplied by the partial pressure of the other product, which is NO2, and you're going to divide the whole thing by the partial pressure of into O3. The units, you need to find the units. The units would be found, the units for pressure that are being used over here are atmosphere. So it's going to be ATM into ATM. So it's going to be ATM squared divided by ATM. And that would give you just a single ATM. That's going to be your unit. Okay, that's the first part. Now moving to the other part. Now they've said that the initial pressure of the entire system is zero point 0.6 atmospheres. And the partial pressure of NO2 is given as 0.48 atmospheres. Calculate the partial pressures of NO and N2O3 at equilibrium, hence calculate the value of Kp. Now remember one thing, that whatever is present in equilibrium in the container, moles would be proportional to concentration, and that would be proportional to pressure. Like if a gas has more moles, then obviously it's going to exert more pressure, right? Sara, is this clear? Abu Huraira, कुछ समझ आया?
Yes, sir.
So moles and pressure are interlinked. I mean, they're proportional. Now the thing is that they're saying that the initial pressure of the partial pressure of NO2 is provided, uh, and that's at equilibrium, right? The
सर
partial
ये
pressure.
फार्मूला P pressure of products सर ये ऊपर ये जो फार्मूला है क्या कौन सा फार्मूला है
कौन सा ये वाला?
Kp is equal to yes sir
वही it's this one के we KC KP and KC we did this in AS कि whenever you have a reaction यहाँ पे whenever you have a reaction तो equilibrium, what is equilibrium? It's either the concentration of the products divided by the reactants or the pressure of the products divided by reactants. Abu Huraira, ये clear है?
yes yes
So By the way, formula, it's HCl squared divided by Cl2 and H2. So pressure of HCl squared divided by pressure of H2 multiplied by pressure of Cl2.
Okay.
Okay. Anyways, coming back to the question. Now the question is that pressure is proportional to moles, right? So I'm going to think of the way I'm going to solve this is I'm going to think of any moles. Like for example, you have I'm going to write down the reaction first. It's N2O3, right? And it's in equilibrium with NO and NO2. Okay, this is the key that you have to think that pressure and moles are directly proportional. So instead of thinking of this as pressure, I'm going to think of this as the moles that are present in the container. Uh, so initially, if you have N2O3, which is 0.6 atmospheres, uh, I mean, you can think of it this way. Like if something is exerting a pressure of 0.5 atmospheres at a particular temperature, uh, and let's assume that's X moles. If the pressure doubles to 1 atmospheres, what does that mean? Like if the temperature is constant and the container's volume is also constant, everything is constant, that means your moles have doubled. You must have 2x moles, like double the moles, right? That's the reason why there are more particles, and the more particles they're exerting a greater amount of pressure, which is why pressure is also exerting. Sorry, do you get this point? Abu Rai, point samajh hai?
Yes, sir.
Sorry, is this clear? Hello, Sarah, did you get this part? Achha, so I'm going to do the same thing over here. And remember one thing uh, about partial pressures or moles or concentration, you're going to get the same result, exactly same value. It doesn't matter the ratio. When you do the ratio product divided by reactants, you're probably going to get a similar value. I said, anyways, what I'm going to do is I'm going to think of this as moles. So initially, my container has pure N2O3, and that's exerting a pressure of 0.6 atmospheres. So let's think of it as 0.6 moles. Like the 0.6 moles initially present. No amount of gas of NO or NO2 is present. There's pure N2O3 present, and that's exerting this pressure over here. And so what I'm going to do is right at the end, I'm just going to convert that back into pressure. Now, at equilibrium, they've given us a few values. Like at equilibrium, they've told us that the partial pressure of NO2 is 0.48 atmospheres. So that means at equilibrium, there's 0.48 moles of NO2 present, right? I mean, I'm just assuming that 1 atmosphere is basically equal to 1 mole. That's just an assumption I'm taking. But I just know that moles and atmospheres are directly proportional. Pressure and moles are directly proportional. And so now what do you understand from this? What you understand from this is that there must have been a reaction. Like initially when you added this into the container, there must have been a forward reaction taking place, and that forward reaction must have produced NO2, and that NO2 is exerting this much pressure. So these many moles must have been created. But if one molecule of NO2 is produced, an equal amount of NO would also be produced. So if there are 10 molecules of NO2 produced, 10 molecules of NO would also be produced. So if there are 0.48 moles of NO2 produced, they're going to be 0.48 moles of so they're going to be 0.48 moles of NO also produced in this reaction. So is this clear? Abu Rara, is this clear?
Yes, sir.
Yes.
So I'm going to write this down that 0.48 moles they got produced. And the same over here, 0.48 moles were produced. Now, since it's 1:1, to produce 1 mole of NO and 1 mole of NO2, you need to react 1 molecule of N2O3. So 1 molecule reacts to produce 1 of this and 1 of this. So if 0.48 are getting produced, these two, then that means 0.48 must have reacted. So 0. Just hold on 1 second. Coming back to the question. So if there's 0.48 moles getting produced, that means 0.48 moles must have reacted. So what are you left with? Like initially you had 0.6 moles, 0.48 have reacted, so you're left with 0.12 moles. Sarah, Abu Huraira, is this clear?
Yes, sir.
Sarah, is this clear? Acha, and I'm going
Yes,
to
sir.
okay, I'm just going to convert them back to atmospheres. I mean that because moles, and I told you that moles and pressure, they're directly proportional. You have more moles, you have more pressure. And I had made this assumption that assuming that they are directly proportional, I just assume that 1 atmosphere is 1 mole. So it's basically 0.48 atmosphere. This is 0.48 atmosphere, and that would be 0.12 atmospheres. And you're going to place that, and you can find the value of Kp. Kp would be partial pressure of NO, which is 0.48, into partial pressure of NO2, which is 0.48 as well, divided by the partial pressure of N2O3, which is 0.12. And you're going to find the value of Kp. Is this clear? Sarah, is this clear?
Yes, sir. Sir, ये 1 ATM is equal to 1 mole. ये हमेशा ऐसे ही होगा?
नहीं, ये तो मैंने ऐसी रैंडम assumption है, वो डायरेक्टली प्रोपोर्शनल था ना. दिस वाज के प्रेशर एंड मोल्स आर डायरेक्टली प्रोपोर्शनल.
अच्छा.
तो वो तो मैंने वैसे ही assume कर लिया कि ठीक है कि k आएगा ना constant. I mean there's going to be a constant, so I just assume कि it's 1. ठीक है. अब ये clear है? Understood?
Yes, sir.
ठीक है. Sarah, is this question clear?
Yes, sir.
Achha, let's move to the next question. Define the following the mathematical expression. This is obviously, you must know that that's minus log of concentration of H plus 1. The other one is Ka for a weak acid. Ka for a weak acid, which is given as HA. I mean, HA dissociates, forms H plus 1 and A minus 1 ions. So Ka is going to be H plus 1 into squared divided by HA. Or you can write it as H plus 1 squared, because these two have the same concentration, divided by HA. Okay, so you're going to write both of the expressions, because I'm not sure which expression he's asking. Write both of them. And so write equations to show how a buffer solution of a mixture of this is the question about buffer solutions. So you have HA that's in equilibrium with H plus 1 and A minus 1. So this ion is its concentration is increased by adding this conjugate base like Na. Anyways, he's just asking what would happen when an acid or an alkali is added. So the first thing is, what would happen if an acid is added? Acid has H plus 1 ions. So what would happen if it's added? If you add more H plus 1 ions, the equilibrium is going to shift in the backward direction. So just write the reaction in the backward direction, H plus 1 plus A minus 1, and it produces HA. What's going to happen if an alkali is added? Like OH minus 1 is added. So OH minus 1 goes and neutralizes. So there's going to be a reaction. OH minus 1 comes in, reacts with H plus 1 to produce water. So H plus 1 are going to get neutralized, which is why the reaction would move in the forward direction. So you're going to write the reaction in the forward direction. So HA would move in the forward direction. The H plus 1 would get neutralized. They would change into water molecules. And who's reacting with its OH minus 1s? Okay, so you're going to write the reaction in the forward direction, except that you have to introduce the OH ions into the equation. The OH ions come in, and on the other side, they're going to neutralize the H plus 1 and turn them into water. Okay, Abu, is this clear? Sarah, is this clear?
Yes, sir.
Yes, sir.
Now, next one. I said this, need this. Okay, this question. Now he's saying there's a reaction when chlorine dissolves in water. The following reaction occurs. So kind of a complicated reaction, but it's like I mean, there's an acid being produced. When solution of chlorine are used for water purification, the pH of the solution of chlorine is kept near to pH 7 by the addition of a base. Chlorine is dissolved in water to produce 1000 cm3 of a solution containing 0.17 moles of HClO and 0.1. I'm going to write that down. So coming back to the question, I'm going to write this. It's a 1000 cm3 solution. Now the reason it's they've probably given you 1000 cm3 is because that gives you concentration as well. So that gives you concentration as well. So this is 0.170 moles. This, so what else is 0.17 moles? This is this is HCl, right? This is HCl. So he's already told you that chlorine is dissolved in water to produce 1000 cm3 solution. Now the concentration would be exactly the same. I mean, all of them would have a concentration of 1.170 mole per dm cube, because this is 1 dm cube. The next part is a buffer solution is then prepared by adding 0.2 moles of NaOH to the solution. The NaOH reacts with the HCl. Calculate the pH of the buffer solution. So the NaOH is reacting with HCl. So what we're going to do is we're going to find out what's going to happen if NaOH and HCl react. It produces NaCl plus H2O. This is 0.170 moles. And this over here is 0.2 moles of NaOH. So that means one of the things is in excess. Like 0.17 is going to react with 0.17 to produce 0.170 moles.
So
This would completely react. And 0.03 moles. And 0.03 moles of NaOH would still be left over.
सर HClO नहीं है
नहीं कौन सा
ऊपर लिखा हुआ ना containing 0.17 mole of HClO
नहीं वो उस पे I'm going to come to that. ठीक है उस पे मैं आता हूँ ठीक है अभी right now there are two acids ठीक है HClO, and he's already told you that HClO is a weak acid. ठीक है let me rephrase everything. there are actually two acids in the mixture. This is the original mixture. There's HCl. So there's HCl and there's HClO. And he's told you that HClO is a weak acid. Okay, I'm going to come to that later. And he's adding NaOH to the mixture, 0.2 moles. Now, the first thing I'm assuming is that it's NaOH goes and reacts with the HCl, right? So there was how many moles of HCl? 0.17 moles. The 0.2 moles of NaOH. They go and they react with it and they produce 0.17 moles of NaCl. So all the HCl has been completely neutralized. And this is present in the solution. Okay, Abu Raya, is this clear so far?
Yes.
Sara, is this clear?
How do you know which one is an excess?
I said, which one? I mean, this is 0.17 moles. I mean, look over here, it's given. They've already told you that that the HCl is 0.17 moles, right? And you're given the moles of NaOH as well. That's 0.2 moles, right? What does the equation tell you? In what ratio do they react? It's 1:1, right? They react in equal quantities, right? So if they are reacting in equal quantities, 0.17 would only react with 0.17. It can't react with 0.2. Sorry, do you get this part?
Yes, sir.
So which is why not all the NaOH would react. I mean, only 0.17 would react. So out of 0.2, if you remove 0.17, they've reacted. 0.03 moles would be left over at the end. Is this clear, Sara? Is this clear?
Yes, sir.
Abu Raya, clear?
Yes, sir.
But the question doesn't end over here. The NaOH would just not react with HCl. It would also go and react with the weak acid, which is HClO. Okay, because I've already told you they've already told you that it's a weak acid. And they've actually, I said, the reason I was reacting it with HCl, I mean, I was just assuming that it was reacting with HCl first. They've actually written it over here. The statement is given that the NaOH reacts initially with the HCl. Okay, so I was just making an assumption. I didn't read that part, but I did it correctly. Okay, my hunch was correct that the NaOH would go and react with HCl. The other part is you're left with 0.03 moles of NaOH. What would that react with? What would that react with? Just hold on 1 minute.
HCl.
Just 1 minute. So 0.03 moles of NaOH are going to react with this weak acid, HClO. Now, HClO and NaOH are going to react. That's the second part. The first part is done. NaOH has reacted with HCl and has completely neutralized the HCl. What would be formed? What's going to be formed is how is the salt produced? The H gets replaced. So it's going to be by the Na. So it's going to be Na and ClO plus H2O is going to be produced. Now, how many moles of HClO did you have in the? I mean, they gave you the moles over here. It's 0.170 moles. It's written over here. It's 0.170 moles. So they're going to react with the leftover NaOH that was from the first reaction, which is 0.03 moles. Now, Sara, again, listen very carefully that one of them is in excess. 0.03 moles are going to react, but with only 0.03 moles. So 0.03 moles would react with 0.03 moles. So out of 0.17, 0.140 moles would not react. They are in excess. Sara, is this clear?
Yes, sir.
So 0.03 is going to react with 0.03 to produce 0.03 moles. It's 1:1. So 0.03 moles of NaClO is produced. So at the end of the day, you have a buffer solution. The buffer solution is going to be, you have a weak acid. So there's this leftover weak acid. Like how many moles? 0.140 moles of HClO. And the other thing is you'll have a salt of the weak acid. The salt of the weak acid is going to be, this is the salt, and that's 0.03 moles of NaClO. So you'll have these two things in the mixture. Now you'll have these two things in the mixture, and I'm going to apply the buffer solution formula, which is that Ka is equal to the salt concentration into the H+1 concentration divided by the acid concentration. So the K value is given. It's given over here as 2.9 times 10 power minus 8. And you can do the math. It's one second, let me just write it down, 0.03. Try and find the value. You can just take a break for 1 minute. So, did anyone try and solve this?
0.9. 6.9.
Yes. Sarah, did you get this question? I mean, this is kind of a very confusing question, and it has very few marks. I'm actually going to.
Yes, 6.95.
Okay. I'm actually going to check. It's 9701 M19 QP. I mean, why did they give so less marks for this? Let's 9701 M19.
बंदा छोड़ दे. नहीं क्वेश्चन छोड़ दे बंदा.
मैं छोड़ दे. Time जाए वाला. हाँ. Just one second. Let me open. Just let me quickly check the marking scheme. This is question number 3. So where's question number? So they had to do the whole calculation. It's so everything has to be done. It's it's coming out to be 6.9 is the answer. Remember one thing, when you're doing calculations and it has many steps, try, although we didn't do any rounding, try not to round values too much during the steps. Anyways, we got the right answer, and you had to do all the calculations. I mean, you had to make the equations in the middle as well, and they didn't give you any marks for that. They must have given at least a few marks for making up these equations. So this one, the next question, try and solve this question. You can send the answers for this next page. I mean, you can ignore these values, this question, but the rest of the questions should be solved. So it's page 13 and page 14. Try and solve page 13 and 14. You can try and send in the answers for this. Chale, we're going to continue with this in the next class then. Okay.
Okay, sir.
Okay.
Okay.
Okay. Take care.
Okay, in the next one.